everyone, it's Justin again. I'm helping set up our community festival, which starts tomorrow. There's gonna be music, slushies, funnel cakes, and more. I'm so glad I volunteered. But I need to finalize the map so we can hand it out tomorrow as people enter. These are the different areas of the festival that need to be included on the map. Somehow, I need to make this map easy to follow. Where should we start? I'm thinking I want to outline each category on the map. Breaking things into categories always makes them easier to understand, so let's categorize the ticket booth first. The ticket booth is part of the information area, so I'll place the information circle around the ticket area. The most important part of the festival, though, is the area with all of the booths, like the food, craft, and game booths. The booth area also includes the information area and ticket booths. And of course, all of these mentioned categories are inside the festival, so the festival area encompasses the entire festival. Our last category is the parking lot. This is a totally different area outside the festival, and you don't need a ticket to enter, so it is a separate group all on its own. The categories make the festival map easy to understand. Do you know what this reminds me of? When we organized numbers into categories in the last unit. In our previous unit, we learned to categorize natural numbers, whole numbers, and integers. Do you remember the definitions of these terms? Pause the video to fill in the blanks in the guided notes. There are examples listed under each definition. Natural numbers are positive counting numbers like 1, 2, 3, and so on. Whole numbers include all natural numbers and 0. And finally, integers are all whole numbers and their opposites. That means all whole numbers and natural numbers are also considered integers. In the previous unit, knowing these categories helped us understand the properties of different kinds of numbers and how to perform operations like adding, subtracting, multiplying, and dividing with different integers. Are there any numbers that don't fall into the categories of integers, whole numbers, and natural numbers, though? What about numbers that are between two integers, like fractions and decimals? Well, there are two more categories of numbers: rational numbers and irrational numbers. I've sorted a list of numbers into these categories. Do you notice any patterns? Pause the video to write down patterns you notice about rational and irrational numbers. All right, first, what do you notice about the rational numbers? I see decimals, fractions, and integers in this group. Do you see the word ratio in rational? Rational numbers are defined as numbers that can be written as fractions. Technically, fractions are a type of ratio. We know that fractions can be converted to decimals too. To do this, we find the numerator divided by the denominator. Pause the video to convert the fractions 1/5 and 2/3 to decimals. To convert 1/5 to a decimal, we do 1 divided by 5, which is 2/10. 2/10 is an example of a terminating decimal. What does it mean to terminate? It means to end, just like the festival will terminate or end after a week. So a terminating decimal has an endpoint, or an exact number of digits after the decimal. Some fractions are equivalent to terminating decimals, like 1/5. For 2/3, we find 2 divided by 3, which is 0.66666, and so on. The 6 will repeat forever. We show this by writing a line over the digit or digits that repeat. This is called a repeating decimal,
because it has a number or pattern of numbers that repeat. Some fractions are equivalent to repeating decimals. So, rational numbers include fractions, terminating decimals, and repeating decimals. I also see the integers, 15, -8, and 0. Remember, any rational number can be written as a fraction. Can 15, -8, and 0 be written as fractions? Yes. The identity property states that any number divided by 1 maintains its identity. Integers can be written as fractions over 1. That means integers are also considered rational numbers. Whole numbers and natural numbers must also be rational numbers since they're types of integers. This diagram reminds me of our map. Just like how the entire festival area includes the booth area, it also includes the information area and ticket booth. Rational numbers include integers, whole numbers, and natural numbers. Knowing how these categories fit together will help us understand types of numbers and their properties. The other category on the original diagram was irrational numbers. Did you notice anything about the numbers sorted in this category? They're all long decimals ending with ... They do not terminate. These decimals go on forever without repeating a pattern. Decimals that don't repeat or terminate cannot be converted into fractions. So, why are these non-terminating decimals considered irrational? Let's break down the word irrational. The prefix ir means not. So, irrational means not rational. Makes sense. If irrational numbers are not rational, they cannot be written as fractions. Irrational numbers are a totally separate category from rational numbers. This is just like in our map where the parking lot was a totally separate area from the festival area. We'll learn more about irrational numbers later on in this course. But now that we know the types of numbers, let's practice identifying whether numbers are rational or irrational. Pause the video here to sort the following numbers into the rational and irrational categories. Check your work. From this list, the -2.4, 1/10, and 26 are rational numbers. All of these numbers can be written as fractions. The last two numbers are non-terminating decimals that don't have a repeating pattern. 2.23606 without an end, and -101.41421 without an end are irrational because they cannot be written as fractions. Great job. Let's take it one step further. Look at the rational numbers here. Do any of them also fit into more specific categories? Pause the video to sort -2.4, 1/10, and 26 into all the categories they belong to. This could include integers, whole numbers, and or natural numbers. Does -2 and 4/10 fall into any other categories? No, it's a decimal, so it can't fit into the other three categories. 1/10 is a fraction, so it can't be sorted into any other category. But 26 is also an integer, a whole number, and a natural number. Nice work. Try one more example. Pause the video here to categorize the following numbers on the diagram. Remember, rational numbers might fall into other categories too. If a number fits into more than one category, record it in each place it belongs. -1 and 2/5 is a rational number, since rational numbers can be written as fractions, and it doesn't fit in any other category. -9.72513 is a non-terminating decimal, so it can't be written as a fraction. That means it's irrational. 3 is a rational number, and it's also categorized as an integer, a whole number, and a natural number. 7.4 repeating is just a rational number. It can't fit in any other categories. And -8 is rational and also an integer.
Categorizing numbers, just like organizing our map, helps us understand their characteristics and know their properties. Whether we're evaluating expressions with the order of operations or just trying to identify numbers, knowing their category makes math much easier to navigate. Tomorrow, I'll be working with ticket sales, perfect for practicing some rational numbers since money uses decimals. I'll be working with rational numbers all day. While I get these maps printed, be sure to finish the guided notes and practice levels 1 through 3. Then, try the activity, sort it out. Until next time, keep exploring, keep calculating, and remember, whether it's maps or math, figuring out where things belong makes everything clearer. See you next time!
Hey, hey.